Hello students, in the last lecture we discussed about indefinite integration. I will move ahead and discuss the next concept, that is definite integration. And I think the question is already communicated to you. Before we move into this chapter, right, there are certain formulas which we need to know. We'll discuss those first. It's a simple chapter, easy to score. What is the first important thing is integration. We know in this the first part we discuss is fundamental theorem of calculus. So integration a to b f of x dx. If this integration, if you say this is beginning first, say f of x dx, if this is the integral, then integration from a to b f of x dx is nothing but, it is, how we write this? This is f of x from, we say x is equal to a to x is equal to b, and the same thing we write as f of b minus f of a. This is what we called as fundamental theorem of calculus. So what is the change in these two? Is it clear to all? Whatever your answer, we just put the upper value minus the lower value and then we get the answer. This is what is called as the fundamental theorem of calculus, right? This is what we are going to use there to solve the questions. Now besides this, there are few formulas, or you can say the properties of definite integration, which we discussed throughout the concept when it was discussed in depth in the class. These are certain rules which are used in definite integration. Right? Integration from a to b f of x dx, we know it is same as a to b f of t dt. So if we change the variable, the answer remains the same. The second property which we discussed is a to b f of x dx is nothing but integration b to a, then we write minus here. This is f of x dx. What is this says? If we interchange between these two limits there, the integral becomes negative. So whatever the answer, will become negative. Third property, which is integration from a to b f of x dx, which is integration, you may say a to c f of x dx, and plus integration c to b f of x dx. So what we have done is this interval, which is a to b, it is a to b. So what we have done is we have divided to a to c. So obviously in this case a is less than c is less than b. So from a to c, and then we are concluded. So that becomes a to c and then c to b, addition of those two. Right? These are the three. Then the next property, which is the most important one and used in maximum questions, is integration from 0 to a. It's the important property. F of x dx. Fine. This is 0 to a. F of a minus x dx. Right? This is the most important one, as I mentioned before, also used in maximum questions. I'll explain how to use this. The next one is integration from a to b. F of x dx is integration a to b f of a plus b minus x dx. A plus b minus x dx. So what happens here? These two values which are there, we write their addition minus x. Right? And the next one is integration from minus a to a. Right? This is a property which is usually asked in objective exams. So you know, in this case there are two answers there. If fx is even, it is 2 times integration 0 to a f of x dx. That is if fx is even. Now what is mean by even is f of minus x is same as f of x. Right? If this happens, then it will become twice. If it is minus a to a, it becomes 0 to a. And this will be 0 if fx is odd. If fx is odd function. What is mean by odd is f of minus x is minus f of x. Fine. So these are the properties which can be used directly to solve the questions. Now there are few more shortcuts, right, which can be used in all these properties, and these answers we know. In fact, when we discuss this in the classroom, we discuss all those properties, and I'll explain those quickly. The first one is integration 0 to a or in this case 0 to pi by 2. Fine. The property which I had mentioned just now is 0 to a f of x dx, which is 0 to a f of a minus x dx. Using this property, if it is 0 to pi by 2, if it is sin x and upon sin x plus cos x dx, if we apply this property and how we get the answer, we know this answer is nothing but pi by 4. Fine. So this answer is pi by 4. Instead of sin, if I change here cos and here sin and cos, still it remains the same. You write the same thing as sin raised to nx, cos raised to nx here. Still the answer remains the same. Same if I replace this sin by cos, correct? This is replaced by cos, the answer will remain the same. If you continue this way, you can see that the same question can be expressed as 0 to pi by 2, it is 1 upon 1 plus tan x, correct? When you write tan is sin by cos, so the same thing can be written as integration. If you take tan as sin by cos, this can be written as cos x upon sin x plus cos x, correct? 0 to pi by 2. It will go into the previous mode there, again it will be pi by 4. So this is this way, you write it this way, or you write raised to n. Fine. Then in this case it will be like this, but the answer will remain the same. What is important here? This should be 0 to pi by 2. If this happens, then the answer is pi by 4. Fine. Then there are few more questions like, now remember these next ones, because these questions if you start solving, the one which I am going to write now, they will take very long time to get the answers. Fine. There are two such properties. One is integration from 0 to pi by 2 log of sin x. Integration from 0 to pi by 2. Please write down in your notebooks. 0 to pi by 2 log of sin x. The answer is minus pi by 2 log 2. Fine. If you solve it by method, then it will take 7 to 8 minutes to get this answer. Remember this particular one. Exactly same is the answer when it is 0 to pi by 2. 0 to pi by 2, it's log of cos x. Fine. Answer is again the same. It is pi by 2 log 2. Fine. The next one is, these are sin and cos. Now if similar question is asked in case of cot, fine, is this clear to all? Write down this. If you change this to, now if you apply the property, say 0 to this property, it is 0 to twice a. So if I change this pi by 2 to pi, 0 to twice a, fx dx is nothing but 2 times integration 0 to a f of x dx. There are other things related to this. So if we change this to pi, then there will be 2 here. So that 2 goes, this 2 gets cancelled. So it will be pi log 2. And if it is 0 to pi here also, the same question will be just minus pi log 2. Right? So this will be the answer if it is 0 to pi. Is the difference clear? If it is pi by 2, there is pi by 2 here, and if it is pi, then it will be 2 times. Fine. Same is the question when it is log of tan x. If it is say 0 to pi by 2, log of tan x, this answer will be 0. And if it is 0 to pi by 2, log of cot x, then this will be 0. Fine. There is a question in my questionnaire where I explain this particular question there. So remember these 4, these are the important ones to be used in different questions there. And let us move ahead into the next part. Fine. You have a questionnaire with you. Let us solve the questions from that. Fine. I noted few questions of those. I'll begin with question number 1 in order. Question number 1 is integration from 0 to 1. It is x square plus 3x plus 2 and upon root x. Fine. This is our first question in the regular course also. We discuss a similar kind of question. Now what can be done in this question? We know what is the method. You can write this as 0 to 1. This can be written as, this in the numerator you can write this as root x there. So it is x raised to minus half. So shall I say this is x root x plus, this is, if we shift it on the top, so we can write this as x square upon root x, I'll say, this is plus 3 x upon root x, and plus 2, it is 1 upon root x kind of thing. Now when it comes to x square, you can write this as x into x. X can be written. Now how to write this x? We know what is x upon root x is nothing but root x. So this can be written as integration 0 to 1. This is x root x dx plus 3 times. It will be just root x dx. And this will be plus 2. It is x raised to minus half dx. X raised to minus half dx, correct? So simplified, so what is x root x is nothing but integration 0 to 1. It is x raised to 3 by 2 dx plus 3 integration, it is x raised to half dx, 0 to 1, and this is plus 2 into x raised to minus half dx, right? 0 to 1. Now what is the next step? Is the next thing visible? So I'll erase this. There is limitation with the board here, right? Or I'll write the steps here. So what will be this integration is x raised to, you know what is integration of x raised to n? Is x raised to n plus 1 upon n plus 1. So this can be written as x raised to 5 by 2 upon 5 by 2. This is from 0 to 1. This is nothing but plus 3. X raised to 1 by 2 can be written as x raised to 3 by 2 by 3 by 2. This is from 0 to 1, and this can be written as plus 2 and into x raised to minus half. So when you add 1, it will be x raised to 1 by 2. So it is x raised to 1 by 2 by 1 by 2. And this is from 0 to 1. So just write this 2 on the top. So it is 2 by 5. And when you write the limit, it will be 1 minus 0 plus 3. This 3 will get cancelled. So you will say 2. It is, right? This 3 will get cancelled. This 2 will go on the numerator. So it is 1 minus 0. And this 2 on the top becomes 4. So it is 4. It is 1 minus 0. So in short, this is 2 by 5 plus 2 and plus 4. Simplify this. So it is 6, and if you take the LCM, amongst the option C is the possible option then. This is 32 by 5. So C is the option. C is the answer. Right? Let us move into the next one. Right? This is question number 1. Yes. Cut now. Yes, we'll move to the next question. Question number 4 in the booklet. Question is integration from minus 2 to 1. It is 1 upon x square plus 4x plus 12 dx. Right. This can be written as integration from minus 2 to 1. Now we have to complete the square here. So this can be written as 1 upon x square plus 4x plus 4 and plus 9. So this addition is 13 there, not 12. It is 13 dx. So this can be written as integration from minus 2 to 1. It's 1 upon x plus 2 the whole square and plus 3 square dx. Correct? This is of the form. 1 upon x square plus a square, and which is 1 upon a tan inverse x upon a times. So fine, you have to use this. So what will be this answer using this is 1 upon 3. Who is playing the role of a is 3. So it is tan inverse x plus 2 upon 3, and from minus 2 to 1. Right? So this can be written as 1 by 3. It is tan inverse. If you replace x by 1, 1 plus 2, that is 3. 3 by 3 becomes 1. And minus, if you replace x by minus 2, minus 2 plus 2 becomes 0. So 0 by, so it is 0. So we know this is 1 by 3. So it is tan inverse of 0. Tan inverse of 1, which is pi by 4. Fine, I'll write directly now. Pi by 4. And tan inverse of 0 is 0. So answer is pi upon 12. So if you look at the option is option D in the booklet for question number 4. Fine, let us move to the next one.
Yes, the next question is question number 6. Integration from 0 to 1. It's 1 minus x square upon 1 plus x square dx. Now there is 1 plus x square in the denominator. Try to adjust the same term in the numerator. So this can be written as integration 0 to 1. It is 0 to 1 there. So it is 1, you can say minus 1, right? And then it is minus 1. To cancel this, we'll say plus 1. So 1 plus 1 minus 1, I'll say. So I added and subtracted 1 and minus x square and upon 1 plus x square dx. Right? So what I done is I added and subtracted 1. But you know what is this 1 plus 1 is 2. So this can be written as integration 0 to 1. It's 2. Minus sign you can take outside from these two. So it is 1 plus x square and upon 1 plus x square dx. Now I can separate these two. So it is integration from 0 to 1. It's 2 upon 1 plus x square and minus 1 plus x square upon 1 plus x square, that is 1 dx. Right. After we separate the denominators. So this then can be written as, this is 2. We know what is integration 1 upon 1 plus x square is. It is tan inverse of x. This is from 0 to 1 and minus integration of 1 is x from 0 to 1. So apply the limit. So it is 2 into tan inverse 1 minus tan inverse of 0 and minus 1 minus 0. So it is 2 into pi by 4 minus 0 and minus 1. So 2 into pi by 2, that is pi by 2, correct? And pi by 2 minus 1. So this should be the option. So just see if it is there. I think it is option A in the booklet. Right? So that is the answer of question number 6. Yes, let us move to the next one. The next question is integration. This is the 9th question, right? Integration from 0 to 9. 0 to 9. It is 1 upon 1 plus root x dx. Now this question can be solved by 2-3 different ways. One of the simplest way is we can substitute for 1 plus root x, right? So instead of substituting for root x, I'll substitute for 1 plus root x. So let us say 1 plus root x is equal to t. So when I say 1 plus root x equal to t, if I differentiate, correct? So it is 1 plus 1 upon 2 root x dx is equal to dt. Is equal to dt. So if we shift it the other side, this is dx is equal to, this will be multiplied here. It is 2 root x dt. But we know the value of root x. What is root x from here? What is root x's value is t minus 1. So if we put this value from here, this can be written as dx is equal to, it is t minus 1. It is 2t minus 1. This 2 as it is, and the value of root is t minus 1 and into dt. So this is what is the change. There will be change in the limit also. So when x is 9, right, when x is 9, if I put x equal to root 9 here, 9 means it becomes 4. So what this implies, t is 4. And when x is 0, if I put x equal to 0 here, if x is 0, what is value of t is 1. Right? So this question then can be expressed using these changes now. So instead of dx, what will come is 2t minus 1. So this question can be written as, instead of 9 there will be 4, instead of 0 there will be 1. So it is 1 to 4. And this function, this is obviously becoming t there. So it is 1 upon t. So it is 1 upon t. And dt is nothing but 2 and t minus 1. Right? This is what is the new question now. Now this is what you have to simplify. So this is a simple question after this. This is 1 to 2, 4. If you bring it inside, this 2 is multiplied to both. So if you want, you can take it outside. So what is remaining is t minus 1 upon t dt. So this can be written as 2. It's 1 minus 1 upon t. Correct? 1 to 4. So it is 2. This is the integral. I have not written the integral there. Dt. So it is t minus log t from 1 to 4. Now just put the values. So what is remaining? It's 2 into, I'll substitute for the first one. So it is 4 minus 1 is the first limit, and the second limit is log of 4 minus log 1. Right? So log 1 is 0. So this can be written as, I'll write the final answer here. So 4 minus 1, that is 2. So it is 2 inside the bracket 3 minus, this is log 4, and what is this minus minus becomes plus 1, log 1 is 0. So it is plus 0. So this should be the answer. So just see the options there. Fine. So it is 3 into 2, that is 6 minus 2 log 4 is one of the options. 2 log 4 is given as 2 log 2. We can write this as, this is 6 minus 2. You may say log of 2 raised to 2. So it is 6. This 2 becomes the multiple. So it is 4 log 2. So this should be the answer, and this is as per the book the option A. Right. So this is option A. Good question. The next one is integration from 0 to pi mod of sine cube x, or you may say sine cube theta d theta, doesn't matter. This question is question number, I think 9. The previous one was 7. This is 9. Okay. Now when it comes to mod, right, it is 0 to pi. Now when it comes to mod, and you know what is 0 to pi, here it is 0, and 0 to pi means you are in first and second quadrant. In first and second quadrant, what is sign is positive, correct? Here also sign is positive, here also sign is positive. So between 0 to pi, sign is also positive. So solving this is same as solving integration 0 to pi of sine cube theta d theta. So no need to write modulus because sign is positive in the first and second quadrant. Now after this the question is simple. We can write this in terms of sine 3 theta's formula. We know what is sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So you can find out the value of sine cube theta. Shifting this here, this side. This can be written as 4 sine cube theta equal to 3 sine theta minus sine 3 theta. And you can divide by 4. Fine. So if you divide by 4, this 4 will go here. Now just put this value here. This is integration 0 to pi, and it is 3 sine theta minus sine 3 theta and upon 4 d theta. It's a simple integral up to this. You can keep 3 outside, or in fact 1 by 4 outside for the entire integral. If you keep 3 outside, integration of sine theta d theta and minus integration of sine 3 theta d theta, and which is from 0 to pi. So integrate and apply the limits. So if we integrate, we know what is the integral of this. Yes, integration of sine is minus cos. So it's, you may say 1 by 4 and inside the bracket 3 into minus sine theta. Derivative of sine is minus cos. So it is minus cos theta from 0 to pi, and minus, it is integration of minus cos 3 theta and upon theta. The multiple of theta is 3, so we have to divide by that. This is from 0 to pi. Right? Then apply the limit. We know what is pi and 3 pi. If we replace here by pi, it is 3 pi. Pi and 3 pi, both values, they come here. Correct? And we know when it comes to cos of pi or cos of 3 pi, they both are equal to minus 1. And cos 0 is 1. So just put the values after applying the limit. Cos of pi and cos of 3 pi both are minus 1. So simplified further, the answer in this case should come to, the question is of sine cube. So it should be 4 by 3. 4 by 3 should be the answer. So simplified further. Yes, let us move to the next one. Question is integration from 0 to pi. This is question number 11. Integration from 0 to pi. It is tan of tan cube x and into sec x dx. Yes, tan cube x into sec x dx. Now in this integral, we know what is derivative of sec theta is sec theta into tan theta. So we need to simplify, adjust it first. This is integration 0 to pi, which can be written as tan square x into tan x into sec x. Right? So this tan cube is written as tan square into tan. Now this tan square again further can be written as integration from 0 to pi. Tan square can be written as sec square x minus 1 and into sec x tan x. Now if you look at this, we know derivative of sec x is sec x tan x. So obviously what you're going to put is put sec x equal to t. So this implies sec x tan x dx is equal to dt. There will be change in the limits also. So the question says pi by 4, not pi. Right. There is pi by pi, then it will be a problem there. So if we substitute when x is pi by 4, what will be t? If you put x equal to pi by 4, what is sec pi by 4 is nothing but root 2. So what is t is nothing but root 2. And when x is 0, right, what is sec 0 is nothing but 1. So this t is 1. So there will be change in this integral then. This integral then can be written as integration sec, we are putting sec as t, so it is t square minus 1 and sec x tan x dx, sec x tan x dx becomes dt. And this is from 1 to root 2. So this can be written as t cube by 3 and minus t, and this is from 1 to root 2. Right. So simplified further, this can be written as then root 2 cube, root 2's cube, right? So it is 2 root 2 or root 2 cube by that first. Minus if I replace by 1, so it is 1 cube. This is the upper limit by 3 minus. If I put t is equal to 1, so it is root 2 minus 1, right? Root 2 minus 1. So this is what should be the answer. You can simplify this further. This can be written as root 2 cube is 2 root 2. Right? If you want, you can keep this 1 by 3 outside. Right? So it is 2 root 2. Because root 2 square is 2. 1 cube is 1. Minus. This is root 2. Right? This root 3 is only for, is it only for the first one? Yes, it is only for the first one. Right, so it is root 2 and this is minus of minus plus 1. So simplify it further. This, you can take the LCM as 2. So it is 2 root 2. 2 root 2 minus 3. Okay. And then, is it correct what I am writing? Yes, this 1 by 3 is for this also, so no need to write. Minus 1. This is minus 3 root 3. 3 root 2 and 3 is multiplied here, so it is plus 3 and upon 3. So what is remaining is 3 plus 1, that is 2. So it is 2 and 3 root 2 minus, and this is, so it is minus root 2 and upon 3. So this should be the answer, 2 minus root 2 upon 3. Is it visible?
Yes.
Okay. Okay, let us move to the next one. Fine. For the next questions, we have this 9 to 9. It is x cube upon 4 minus x square dx. X cube upon 4 minus x square dx. Now again it is the same question. If I say f of x minus a to a type, so it is x cube upon 4 minus x square. What is f of minus x is minus x cube and upon 4 minus minus x square, correct? So what is minus x cube is minus x cube and upon 4 minus x square, negative x square, square is positive. What is this? Nothing but f of x. So it is minus f of x. So f of minus x is minus f of x, means this function is odd, and since it is odd, the answer is 0. What is the property says? Minus a to a fx dx is 0 if fx is odd. So that is what is used. So for odd function the answer is 0. So that's the answer. So that should be option, and that is option number A in question number 34. Let us move to the next one, question number 38, which is one of different kind of questions. It is integration from 2 to 4. 2 to 4 log of x square upon log of x square and plus log of 36 minus 12x and plus x square dx. Now everything is expressed in terms of log, but this can be simplified. This is 6 square and this is x square, and 6 into 2, that is 12. So this is a perfect square. So if you look at this is the square of what? 6 minus x, the bracket square, right? So we can write the same question as integration 2 to 4. It is log of x square upon log of x square and plus log of 6 minus x square. Now if you look at this question is again of the same type. What is addition of 2 plus 4? So it is of the form integration a to b f of x upon f of x plus f of a plus b minus x dx, which is b minus a upon 2. So if you apply the same thing here using this property, what will be this answer? Is nothing but b. What is b? Is 4. So it is 4 minus 2 upon 2. So it's 2 by 2. Right? So answer should be 1. Right. And that is one of the options. I think option E. So that is the answer. Let us move to the next one. The next one is integration from minus 1 by 2 to 1 by 2. It is 1 plus x cube and upon 4 minus x square dx. So again it is of the form minus a to a. Just separate the denominator first. So it is minus half to half. It is 1 upon 4 plus minus x square and plus integration minus half to half. It is x cube upon 4 minus x square. Now in the previous question itself we said that this is odd function, and obviously if you replace x by minus x, this will be even function. Correct? This is even. So since it is even, we can write this as 2 times integration 0 to 1 by 2. It's 1 upon 2 square minus x square dx. And answer of odd function is nothing but 0. So simplify it further. So it is a square minus x square. So it is 2. It is 1 upon twice a log of a minus x upon a plus x. So it is 2 plus x upon 2 minus x. And this is from 0 to half. Now just replace x by half there. This 2 and 2 gets cancelled. Right? This gets cancelled here. So the answer will be, if we put x is equal to half, so it is half plus 2. So it is 2 into 2, 4 plus 1, 5 by 2. So it is 1 upon a log of 5 by 2. And if we replace half, so it is 4 minus 1, that is 3 by 2. 2 gets cancelled. So answer should be 1 upon a log of 5 upon 3. Just see that the option is there. And in 35, this is question number 35. Right? The answer is, I think, A. So A should be the option. Right, so that's the answer. And the next one. The question is integration from 0 to pi by 2. It's log of cot x. Fine. This answer should be 0. We discussed in the beginning what is log of cot x. You can use integration 0 to a f of x dx, which is integration 0 to a f of a minus x dx. So if you call this as 1, or say I, which is equation 1, if you apply this property, right, using this property, what will be this? Is 0 to pi by 2. It is log of pi by 2, cot of pi by 2 minus x. What is cot of pi by 2 minus x? Is nothing but tan x dx. This is equation 2. If you add these two, so 1 plus 2 gives you 2i is equal to integration 0 to pi by 2. It's log of cot x plus log of tan x. Fine. This can be written as integration 0 to pi by 2. It is log of tan x into cot x, correct? Using the properties of logarithm. What is that is right here? It is integration from 0 to pi by 2. It is log of 1, because we know tan and to cot is 1. So it is log of 1, and what is log 1 is 0. So it is integration 0 to pi by 2 of 0. So answer is 0. If 2i equal to 0, obviously I equal to 0. So this implies I is equal to 0. So answer of this should be 0. Okay, so just see if that option is there. That is option C. So C should be the answer. Yes. This is one question which is given there. I don't know the question number there. I have not noted the question. This is 0 to pi by 2. It is 1 upon a square sin square x plus b square cos square x dx. A square sin square x plus b square cos square x dx. Now we know when it comes to square, there is a standard substitution. What we do, we divide the numerator and denominator by cos square. So divide the numerator and denominator by cos square x. So this then can be written as 1 upon cos square, which will be sec square x. In the denominator, sin square by cos square will become tan square. So it is a square tan square x. And plus b square cos square by cos square will be 1. So this question will look like this. This is 0 to pi by 2. Right? The question is from 0 to pi by 2. Now this what is remaining there. We know in such questions, what is the next step is we put tan x equal to t. We know derivative of tan is sec square. So what we do is we put tan x is equal to t. So this implies sec square x dx is equal to dt. So this sec square x and dx will go. There will be a change in the limit when x is pi by 2. What this implies is if you replace x by pi by 2, what is t will be infinity. And when x is 0, if you replace x by 0, you know what is tan 0 is nothing but 0. So it is 0. So it is integration from 0 to infinity. So this question then can be expressed as integration from 0 to infinity. Sec square x dx becomes dt, and this will be 1 upon a square t square plus b square. So this can be written as integration 1 upon a t the whole square, and you may say b square dx. This is from 0 to infinity, and we know what is the integral. It is of the form x square plus a square. So it is 1 upon a, who is playing the role of a is b. It is tan inverse a t upon b, but the multiple of t is a, so you have to divide by a. So it is actually upon a, and this is from 0 to infinity. So this can be written as 1 upon ab, right? This a and b, and it is tan inverse. If I replace it by infinity, so it is tan inverse of infinity minus tan inverse of 0. Fine. What is tan inverse of infinity is pi by 2, and tan inverse of 0 is 0. So what the answer is 1 upon ab, and into this is pi by 2. This will be 0. So answer is pi upon 2ab. So this should be the answer. So pi upon 2ab should be the answer. Fine. Take one more. Maybe the last one from this particular part. Fine. The question is integration from 0 to pi by 2. This is one of the important questions which is there in your textbook also. Question is log of 1 plus tan x. Fine. It is pi by 4, not pi by 2. Pi by 4. Fine. So in this question, you know, we can write this pi by 4 here using the integration 0 to a f of x dx, which is integration 0 to a f of a minus x dx. So applied, this can be written as integration 0 to pi by 4. It's log of 1 plus tan of pi by 4 minus x dx. this then can be written as integration 0 to pi by 4, it's log of 1 plus, you know what is tan pi by 4 minus x is 1 minus tan x and upon 1 plus tan x. So simplify it first, take the LCM, this can be written as integration from 0 to pi by 4, it is log of, if you take the LCM, it is 1 plus tan x minus plus 1 minus tan x and upon this is 1 plus tan x. Correct? This can be written as this tan and tan goes, and if you use the property 1 plus 1 is 2, so this can be written as integration 0 to pi by 4, it is log of 2 upon 1 plus tan x dx. This can be written as pi by 4, integration 0 to pi by 4, it is log of 2 minus log of 1 plus tan x using the properties of log. Log 2 is a constant, and what is this integral? If we separate it, so it is log 2, right? There is I this side, which is equation 1. We are going to call this as I, so I'll call this as equation 1. So it is I is equal to log 2 integration 0 to pi by 2 of 1, and what is this part is nothing but I again, right? After separation, this is 0 to pi by 2 here. So this is nothing but I, this becomes 2I, so it is 2I is equal to log 2, and it is integration of x, 1 is x, 0 to pi by 2. So the final answer, this gives you I is equal to this 1 by 2, this is log 2, and this is pi by 2 minus 0. So this is pi by 4, so you will say pi by 8, pi by 2 into 1 by 2. So it is pi by 4 log 2 should be the answer. So pi by 4 log 2. Okay. So this is how such questions can be solved. This is 1 plus, so it is I plus I is 2I log 2 pi, it is pi by 4 here, not pi by 2, so it is pi by 4. There is pi by 4, so it is pi by 4 here, so it is pi by 8. It is pi by 8 log 2. So remember this as one of the important questions, okay? So we'll stop here with this. Okay, thank you. Okay. Question number 17, which is one of the shortcuts in such questions, that is integration a to b f of x upon f of x plus f of a plus b minus x dx. Or the similar question can be asked as integration a to b f of a plus b minus x upon f of x plus f of a plus b minus x. In both these cases, either here or here, the answer is b minus a upon 2. So the upper limit minus lower limit upon 2. So check here, function is here. Now if you see a similar question here, right, this particular type, say the question which is question number 18, which is 1 to 2, it is root x upon 3 minus x and plus x dx. Right? If you see this question and this question, it is almost similar. Who is playing the role of fx is root x, and who is playing the role of a and b, that is 2 and 1. So there is a plus b, there is a plus b which is 3. So this answer should be b minus a by 2. So b minus a, that is 2 minus 1 upon 2. So answer is 1 by 2. Right. Similar question of this type, I'll take one more. And this is not there in the booklet, just quickly integration. I'll say 7 to 4. So what is 7 plus 4 is 11. So I'll say 11 minus x the bracket square upon say 11 minus x the bracket square and plus x square. You can see this question is similar to the previous one. What is 7 plus 4 is 11. So the answer should be 7 minus 4 upon 2. So 7 minus 4, that is 3. So 3 by 2 should be the answer of such question. Right? I hope the shortcut is clear to all. Yes, let us move to the next one. The question is integration 0 to pi by 2. This is question number 20 in the booklet. It's a good question. Question is sin x minus cos x and upon 1 minus sin x cos x dx, right? So what we'll do in such questions, what we do there, we call such interval as I. I'll call this as equation 1. Then use integration. You know what is 0 to a? Yes, the integral is 0 to pi by 2 here. The integral is 0 to pi by 2. So integration f of x dx is integration 0 to a f of a minus x dx. Right. So if I apply this, who is playing the role of a here is pi by 2, and what is sin pi by 2 minus is nothing but cos, and what is cos pi by 2 minus is nothing but sin. So in this question, if we apply this property here, so this then can be written as integration 0 to pi by 2. It is cos of x minus sin of x. So it is 1 minus cos x and sin x. Now what is the difference between these two equations? It's just the difference of the position. There is sin and cos here, there is cos and sin. So if you take the minus sign outside, it will be similar to the first equation. So this can be written as I is equal to minus. So it is sin x minus cos x and upon 1 minus sin x cos x. In product you can write it in any order. It's equation 2. Now if you look at equation 1 and 2, it is the same thing. So if we add 1 and 2, so equation 1 plus 2 implies 2i is equal to, it is the same quantity, once it is plus, once it is minus, so whatever that is 0. If that is 0, then what is I is equal to 0? I equal to 0 means this answer is 0. So the option in the booklet is D. The answer is 0. Let us move to the next one. It is a similar kind of question which is expressed in terms of cortex. Okay. Question number 22 in the booklet. Fine. The question is integration from pi by 6 to pi by 3. You know, pi by 6 is nothing but 30 and pi by 3 is nothing but 60. So that is 90, and it is 1 upon 1 plus cot x. 1 plus cot x. So we can write this as, you know, cot is nothing but cos by sin. So if you write this as cos upon sin and take the LCM, the same question can be written as pi by 6 to pi by 3. It will be sin x and upon root of sin x and plus root of cos x. I hope this is clear to all. We have written cot as cos by sin. Now if you look at this question, it is again of the same type. It is again of the same type. What can be written as? This we can write as a plus b. What is a plus b here is pi by 6 and pi by 3. So it is just like integration a to b f of x and upon f of x plus f of a plus b minus 6 kind of question. Right. What is a plus b is 90. So what is sin of 90 minus is nothing but cos. So what should be answer? We know such answer is b minus a by 2. So same will be the answer here. So it is pi by 3 minus pi by 6 and upon 2. Pi by 3 is 60. 60 minus 30 is nothing but 30. So it is pi by 6 by 2. So ultimately it is pi by 12. So pi by 12 should be the answer of this question. So if you look at the options, it is option A. Right. So that is the answer. Let us move to the next one. Question number 24. Right. This is a modulus question. We have discussed the shortcut for such questions again in the regular course. If you go by method, it takes time. So if we are given a question of this form, question is 0 to 3. 0 to 3. It is mod of x minus 2. Mod of x minus 2 dx. Fine. If you can recall, we know what is the graph of mod x minus 2. What we do is we equate this equal to 0. So you get x is equal to 2. So we know the graph of mod x minus 2. Right? At x is equal to 2. When you equate this equal to 0, you get x is equal to 2. So there will be 2 here somewhere. There is 1. There is 0 here. There is 2, 3 here. So it's a graph which is like this. Now if this is the graph, if you put x is equal to, our limit is from 0 to 3. So if you put x is equal to 0 here, if you put x is equal to 0, what will remain here? What is our function is f of x equal to x minus 2. So what will be f of 0? F of 0 if you put, that is nothing but mod 2. Mod of minus 2, you may say 2. So this height here is 2 and we know this base here, this 1 plus 1, so it is 2. Fine, this length is 2, so 2 into 2. So this is a triangle, so what is the area of triangle is 1/2 base into height, 2 into 2. Now here there is 3, so if you put x equal to 3 here, so what will be f of 3 is nothing but 3 minus 1, so it is 1. So here the height is just 1. And what is the base is also 1. What is this distance is 1. So it is again 1/2 base into height. Base into height. So what is that is 1 into 1. So what is this answer? 2 gets cancelled. So this answer is 2. Or this area is 2. Actually what we do in integration, when you integrate something, what you get is the area under the curve. So this area is 2 and this area is half. So 1 by 2 into 1 into 1. So what is that is 2 into 2, 4 plus 1, 5 by 2 should be the answer. So this answer is directly 5 by 2 if you know the graph of mod x. Right? So answer is 5 by 2. So just see if that option is there. That is option C in the booklet. Fine. Let us take one more question of the same type. Or you can try similar question at your own. Fine. You do it at your own. That will be better. Next one is question number 28. Question number 28 is integral part of x. All of you know what is integral part of x. Question is from 0 to 3 and it is integral part of x dx. Now when it comes to integral part of x, we know what is integral part. When x is between 0 and 1, when x is between 1 and 2, and when x is between 2 and 3, what is integral part of x is nothing but 0. The greatest integer less than or equal to given number. Fine. So it is equal to here. Fine. What will be integral part of x here is nothing but 1, and what is the integral part of the next case is nothing but 2. So between 2 and 3, this is the answer. And by using the property 0 to 3, we can divide this into 0 to 1 of integral part of x plus this is integral part from 1 to 2 of integral part of x and plus integration 2 to 3 of integral part of x. Fine. But these values we know. Between 0 to 1, what is the integral part of x is nothing but 0. So the first part is integration 0 to 1 of 0 dx. The second part is here between 1 to 2, it is 1. So it is integration 1 to 2 of 1 dx. And the third one is integration from 2 to 3 of 2 dx. You know, integration of 0 will be 0, so no need to solve that. This is x from 1 to 2 and this is 2x from 2 to 3. So if you apply the limits, you will get the answer. So what is this is 2 minus 1, the first answer, and plus if you replace x by 3, so it is 6 minus 4. So what is 2 minus 1 is 1, and what is 6 minus 4 is 2. So answer should be 3. So 3 is the answer. Just see if it is there in question number 28. It is option C. Right? So C should be the answer. So any integral part of question, you need to know the definition first. If you know the definition, you can easily solve the question. Let us move to the next one. Integration. Question number 30. Fine. Now this question I am not going to solve. I have given you the direct method. You have to remember this question. Otherwise it is going to take very long time. So it is log of sin x. There is shortcut for this. The answer is minus pi by 2 log 2. Remember this answer. Same will be the answer if it is integration 0 to pi by 2 of log of cos x. Fine. Remember this question. Otherwise it's a very long process. This one, or if it is 0 to pi log of sin x. What is that is? I mentioned in the beginning. What is that is? Pi log 2. Well, it's multiplied by 2, so 2 gets cancelled. And this is integration 0 to pi. It is log of cos x. So this should be the answer. If it is pi by 2, it is pi by 2 log 2. And when it is 0 to pi, it is minus pi log 2. Instead of this, if there is sec and cosec here, it will be same answer, but it will be plus. Remember these four formulas there. Next one is integration minus a to a. Now these are important ones. Minus a to a minus x and upon a plus x dx. a minus x upon a plus x dx. So what we do in such questions, we don't want this a minus x here in the root. So what can be done here? We can write this as integration minus a to a. Now if I have to remove the root, obviously I have to multiply by the same quantity. So it is a minus x into a minus x, a plus x here, a minus x, and in the denominator there is a plus x and into a minus x. So what I have done is I have multiplied by the same quantity and I have divided by the same quantity. When I multiply and divide by the same quantity, this will become like integration from minus a to a, the square of it. Right? This is a minus x, the bracket square, and in the denominator it will be a square minus x square type. So it will be of this form: a plus b into a minus b is a square minus b square. Now in the numerator there is square and there is square root, so both will go. So same question then can be expressed as it's a minus x, and in the denominator there is just a square minus x square dx. Right. So this is what is remaining. This is from minus a to a. Right. So this integral can be expressed this way. Now if we separate this, I'll write it here. This integration from minus a to a, I'll write a here, and it is 1 upon under root a square minus x square dx, and plus, or you may say minus here, it is x upon under root a square minus x square minus a to a. Now henceforth the question is now divided into two parts. Right? This a is here, this a is of the previous step. Now if you look at this, you have to identify whether it is even function or odd function. So if you replace x by minus x here, fine. So first question, if you replace x by minus x, fine. So if f of x is 1 upon under root a square minus x square, then what this implies is what is f of minus x. If I replace x by minus x, it will still remain the same. So it is a square minus x square dx. What is that? Is nothing but same. So that is what is f of x. Means what? This is even function. And in the second case, if we replace, or if we call f of x as x upon under root a square minus x square, right? Then what is f of minus x is nothing but minus x upon under root a square minus x square. You can see this and this is same, only minus sign difference is there. So what is this? Nothing but minus f of x. This part is fx here. So this is odd function. This is even function, this is odd function, and we know what is integration minus a to a of even function. So using this, what will happen to this is, this can be written as 2 times integration 0 to a of 1 upon, right, this a will still remain here, 1 upon a square minus x square, and you know for odd function the answer is 0. We discussed that in the properties there. Now this is a simple integral a square minus x square type. So this can be written as twice a integration of a square minus x square. It is sine inverse x upon a. Right? And this is from 0 to a. So just put the values and get the answer. Replace x by a, so a by a becomes 1. So it is twice a into sine inverse of 1 minus sine inverse of 0. And you know sine inverse of 1 is pi by 2. Right? So answer is twice a into pi by 2 minus 0. Is it visible? So this 2 and 2 gets cancelled. So a pi should be the answer. Just see if this option is there in the questions there. So there is a pi, that is option D. Right? So D should be the answer, a pi. This is one of the important questions there. Let us move to the next one, which is x cube. Question